Welcome to Processing and Media. This is part 1, and we're going to be looking at exercises 1 and 2. The point of all this stuff is to learn to use processing to actually create media, create images, and particularly in this case, create and manipulate video. So instead of being enslaved to Photoshop and using the effects that Photoshop has, and if Photoshop doesn't have the effect, then we can't use it. We're going to be able to write our own effects and change our own things. We can also manipulate video in a similar way. So let me just close this example and start us along. We are going to be going to the Learning Processing book, our course textbook. And a lot of what we're doing here in today's lecture is from chapter 15. 15 deals with images, and chapter 16 deals with video. We're not starting right at the beginning of 15 here, but because some of this stuff we already covered last quarter. But we're going to start with setting pixels, and we're going to be moving through a number of these components in here. We're not going to deal with mapping 2D images into 3D. That's very cool, but we're not there yet. And then we're going to deal with some video stuff over the course of these several lectures. So we're starting off example 15.5, setting pixels. And it looks like this. There we go. Now, remember, Chapin's really got a lot of resources out here. The book is good. The book is really very good. The examples are decent, and he lectures on this stuff up at Vimeo. He's got all his lectures there. So you don't need to just listen to how I'm doing it. He can explain it too. So you can get him explain how the pixel array works, which is one of the key things we're going to discuss today. We can also go down here and he explain what an array is, how arrays work with loops, all this kind of good stuff. So remember, he's on Vimeo. It's called the lectures for his class at the ITP at NYU called Introduction to Computational Media. Great alternate way to get this stuff explained to you. All right, so let's start off with looking at these things in processing. Look at it. If we step over here and pull up a page on the Learning Processing book, he talks about pixels, pixels, and more pixels. We have this grid down here. You see the grid? He numbers the pixels in the grid. This is a little tiny image, only 5 by 5, and points out that although we see them this way, the image is actually stored in processing as a linear array. Yeah? That's the way processing does it. That's the way Java does it, right? Processing doesn't really invent much of its own stuff. So we're going to look at taking these images, converting them into these shapes, and then manipulating them. So he starts off with this simple example of setting pixels. But before we go there, let's just go back and remind ourselves about how this whole putting images into processing works. So here's classic simple thing, right? We have a P image at the top here called beach. We have a setup. The setup tells us that this is the size. Why do I have that particular size? Because that was the size of the photograph I found on the internet. It's called beach. It's 511 pixels wide and 319 pixels high, okay? And we're going to draw it, put a background in there. Why is there a background if I'm going to put an image on it? Okay, because in a moment, we're going to try and make it transparent. But right now, there's a background, and then we're putting the image on top of it, and we look at this, and ta-da, it's a beach, right? Lovely beach. You prefer to be there, I'm sure, than here right now. But we can't all choose. So here's our thing. Now we're going to try and add something to change this, just to, get back in the groove of dealing with images. So we're going to practice with a little tint command. So there's lots of methods for messing around with things. Tint is one of them, and I'm going to set this tint to be influenced by the mouse X. The mouse X ends up being a little bit big, so I'm going to say mouse X minus 2. Why mouse X minus 2? Well, mouse X will go in this image from 0 to 200 and 511. If we divide that by 2, we'll get something that goes to about, well, look, it's almost 256, right? So really, that's the range that we want our tint to go. Most of our colors go, and most of our grayscale. It's always 0 to 255, right? So this sets us up for about the same thing. So coincidentally, 500 pixels happens to be a really useful number. Now if I run this, it's black. Oh, but it's black only because of where the mouse is. As I pan the mouse across, it comes back and forth. So this initial tint here that we're seeing only affects one thing, the grayscale, right? So it's not laying a color across it, it's laying a blackness across the picture. So we set the tint before we show the image in the same way that we set a fill before we draw an ellipse, right? You set what the fill is and what the stroke is, and then you do something with them. It's like, do you pick up the thin pencil or the thick pencil? Do you pick up the black ink or the blue ink? So here, we're deciding that we're going to tint it, and it happens that we're doing this draw a million times a second, well, 60 times a second, and we're setting the mouse each time, and then we're imaging it with that particular level of darkness. All right, we're all on the same page here? Okay, now we've reminded ourselves of that. Let's go look at what we have here from Daniel Schiffman. So here's his example. Let's just look at it, see what it does. It shows us this kind of black and white and gray picture, yeah? Kind of staticky, it's square, it's 200 by 200 pixels. So let's just walk through this step by step here. It says size 200, okay, we're good with that. And then down here, load pixels. So load pixels, and he describes this in the book, and he gives a detailed lecture on it. I just pointed out both of those, so you can track both of those down if I'm going too fast. This takes those 200 by 200 pixels and puts them into one long list of numbers. Yeah? An array is a list. Yeah? So it's a long list of numbers, and in this case it's the pixel array, and this his example that we just showed you in the book had 5 by 5, which meant that his array was 25 long. Here it's 200 by 200, so the array is going to be 40,000 pixels long, right? Which sounds like a long list. 40,000 numbers, yeah? But it works. It's not a problem. So now we have something a little bit more complicated here. We're setting up a loop. We're going to loop through every pixel. So we're going to go looping here for I starts at 0 and goes through the length of the pixels. Okay, that's fine, fair enough. And we're going to add 1 each time. So we're going to go through the entire array, 1 by 1. It's like going through any list, item by item. Just start at the beginning, go through till you get to the end. Pretty straightforward. Then we're going to pick a random number for each time. Random number between 0 and 255. Okay, that's easy enough. And we're going to convert that into a color. So the color command here will generate a color. Excuse me. And that color will be grayscale if you put 1 number in here. It'll be grayscale and alpha if you put 2 numbers in there. It'll be red and green and blue if you put 3 numbers. And it'll be red and green and blue and alpha if you put 4 numbers. This is a phenomenon called overloading, if you're curious, but the same command can actually do several slightly different things. So in this case, it's creating a pixel color, which we're putting into C. This is an object called a color, right? We've had ints, and we've had floats, and we've had strings. We just have a color now. And then I'm going to say, we're going to set the pixel at the particular location. Remember, I is our counter as we're going through. So we say pixels I, pixels is the list of pixels, equals C. That's that particular color, random color that we just pulled up. And then at the end, we have to show it on the screen. So we put update pixels in there. And we run this, and there it's gone through, and every single time it's pulled up a different random grayscale. Some of these are white, some of these are black, most of these are different shades of gray. And you should notice that every time I run this, oh, come on, where is it? There it is. Every time I run it, it will be different. Turn it off, turn it on, turn it off, turn it on. Every time it's different. Yeah? Okay, now we got that one. Let's step into a slightly different example. I've taken the same thing here, except you remember that one didn't have any setup or draw. Now we're putting a setup or draw in here. So pretty straightforward. There's the setup. I put the size inside of it. Here's the draw. And we're loading the pixels and we're updating the pixels. And in fact, everything else is the same. I just added a setup and a draw. What that's going to mean, though, is that this part in here doesn't just happen once. It happens again and again and again, 60 times a second. So if I run this now, we get that old television effect, you know, where the TV's tuned to static. Not you get that on cable, but if you find an old enough television, you can get this effect, and it's got a certain kind of classic old-timey feel to it, yeah? So this is generating a random speckly background. Now, next thing we could possibly think about doing here, back out of the draw and the setup, and do this a different way, right? He used the load pixels and the update pixels, but we could do it a slightly different way. Why am I teaching you two ways here? Mainly because you'll encounter both examples on the internet at different times. So I've modified his example now so that I'm creating a P image here, and I'm using this create image command. The create image command will make a blank image, essentially. So instead of doing a load image of, say, a beautiful beach or a woodland scene or something like that, this will create an image that is 200 pixels by 200 pixels and is in RGB, red, green, blue. Yes? And then here, I'm going to set the size of my stage to 200 by 200, same size. That helps a lot. Now, this load pixels bit down here, we don't actually even need to do it. Yeah, we can delete that. We don't need to load the pixels in this case because we're going to refer to them. Once you have a P image, here's the secret. Once you have a P image, there already is a pixels array for it. Remember what I said before? That's how Processing and Java think of images. They think of them as one long list, not as a grid. You have to tell them how wide the grid is, and then it works out where each one goes and builds it into a grid every time it shows it, but it thinks of it as one long list. So here, we don't need to do the load images because we're not pulling something from the background into that pixel array. We're using a pre-existing pixel array we created up here, which is the My Image pixel array. So you see right here where I have it highlighted, My Image pixels. So we're doing the same loop here where we're just going straight forward from 0 all the way through to the length, and then we're going to pull our random number, pull our random color. Essentially, it's all the same thing, right? Hey, shouldn't be any different. So if we run this, there it is. We get our same image all over again. So with this, we can say, hey, we're really doing the same thing, but we're not using the load image update, load pixels, update pixels. We're doing it a different way. So why would you want one? Why would you want the other? Couple different reasons. This one here, you're working on a specific image that you're changing, and then you're just doing the image at the bottom, right? You don't need this update pixels here. You just need to image it at the bottom. So the load pixels and update pixels changes what is essentially the background. The background is a special class. It's not truly the same thing as a proper image, whereas this is really a proper image. So if we move along, so let's look at this thing for exercise 2. This is almost the same as what Shapen has. I've modified it a little bit. I called my image destination. Okay, so just to emphasize that we're going to work on it for a while and then we're going to output it. So P image, it's called destination. There's my size. Here's the background. The background is 255, 255, 0. That's bright yellow. Why bright yellow? Because we're going to mess with transparency here. And we want to know when we're seeing through our image to the background. And if the background's bright yellow, then anytime we see bright yellow, we go, hey, that's the background peeking through. So destination is going to be using this create image command, right, which just creates a blank image. It's going to be set to width and height. Yeah, well, that's 200 by 200. It's kind of the same as we did a moment ago, but now we're actually just using the pre-existing width and height that comes with using the size. And this is set as ARGB. What's the A? Alpha, right? So most images we deal with have an alpha layer in them too. A lot of Photoshop, most PNG files, not JPEGs, they're only RGB, but most things have an alpha layer in there. So we're going to, again, loop through every pixel. We're going to go from the beginning to the end. If it's 200 by 200, that's 40,000 long in our pixel array, which is a list, yeah? So this thing here, destinations.pixel.length, is going to be 40,000, or actually it's going to be 39,999 because we start counting at 0. We're going to come up with two random numbers this time, rand1 and rand2. Why 2? Because we're going to have a grayscale and an alpha. So here we go. Here the color, just like last time, except this time we're putting in two possible things. So it's going to have a random black to white, and it's going to have a random see-throughness. So we could have a really black color, but it's mostly transparent, or we could have a really black color that's really solid, or we could have a really light gray that's mostly transparent, or we could have a really light gray that's really solid. So the effect is going to be, because we have this bright yellow in the background, that we actually have three colors going on. We'll have black and white and yellow. Okay, you could say, black and white aren't really colors. Give me a break. So, and we're setting each one of those 40,000 pixels to be equal to this in turn. And then at the very end, we're going to put it to our destination. So let's try that. Ta-da! There's our picture. Doesn't it look beautiful? So you can look in this closely, and you can see that there are some pixels in here that are really gray, that have no yellow in them at all. We're seeing a fair bit of yellow because the odds of something having a really low alpha, meaning to say, a really high alpha, meaning that it's really solid, are only there. Most of the things are going to be, on average, 50% transparent. So we're going to have a lot of yellow leaking through to some degree or other, yeah? But there's a speckling of white in here, and a speckling of black, and then a lot of grayish yellow in various shapes. And of course, every time we do this, it looks different. Okay, so this is the first step for exercise 2. But now we want to actually tweak it. All right, so we're trying to go from this, which I hope is relatively apparent as to what's going on, to this. Okay, so what's going on here? What's going to be different? So we got to analyze the problem, trying to sort it out one way or another. There's two things happening here. One is that this isn't just a matter of transparency anymore. We've actually got some colors going on. So we're messing with some randomness in color. It's looking like it's the red, green, blue that we're playing with, and then we're also changing from top to bottom here. Yeah, going down and up. So come on here. There we are. So so we're going to try and fade from solid at the top to very light at the bottom. So let's put this aside as we think about how to do it. First of all, down here, we've been dealing with color as two things. But now we're going to have to really have more in here. A red, a green, and a blue. So first of all, let's just forget the fade from top to bottom and deal with messing with the other stuff. I'll tell you right off the bat, we don't even need a second random number in here. So I'm going to take rand2, take it out. It's gone. But we are going to need to have several different random colors in here. We're going to need to work out where we want to put it, yeah? So we can have 255, comma, rand1, comma, 255. Let's look at that. Run this. Hello? Run this. Okay, this is something there. We've got some pink and some white going on, but it's not quite what we're after. Let's try moving that rand around to see if it'll work better somewhere else. What if it's the first number? And 255. Oops. Too many commas in there. Okay, let's run this one. Blue. I don't think that's quite what we're after either, is it? All right, so that's blue. You know, that's blue and white too. A lot of what we were looking at before didn't our ideal thing, which has disappeared since, has didn't have any white in it. It was all dark, right? So maybe we should actually be, instead of doing the aiming towards 255, 255, 255, aiming at something being lower, like zeroed out. So what if we zero out the blue portion of our affair? What does that look like? Oh no, if the blue goes out, then no, that's not right at all. Then it's so let's try the middle one then. 255. Let's change this one to 0. Ta-da! Okay, so now we've got the right color scheme going on, but we have to make it be darker at the top and go down to be lighter at the bottom. What do we have to change with that? Well, we have this array here, our only array, the pixels. And the pixels go from 0 to 40,000. And although they go across the top, they go 1 to 200, and then 201 to 400, and then 401 to... So really, the difference side to side is very small, because the distance top to bottom is what's taking us mostly from the low hundreds up to 40,000. So top to bottom is what we're doing, is what it's going to be giving us here. So we need to get I involved. I right here. So we need to put have that somehow in one of these colors. And I think that that it's really going to be the middle color here, the one that we set to 0. Now, what we want to do is have a range of colors in here where, because you remember, it went up to white when this was higher, right? When this is 255, then it's got that pale color. And when it's 0, then it doesn't. So this is the one that we want to mess with. So how are we going to mess with it? I say that we take I, and we want to get I. Now, if we put it here, we're going to have a number that's going to go all the way up to 40,000, which is just way too high, right? So we need something that'll divide 40,000 and bring it down to a number like 255. So what's 40,000 divided by 255? Turns out it's about 200. So if I divide it by 200 in here, I get this. There you go. So you can see it's got that full, as though it's 0 at the top, and then it gets lighter and lighter as it goes down. Yeah. So this is our target for exercise 2. What should you really understand, and what should you not worry so much about? Part of this is about problem solving, about trying to mess around with the color and get the effect you wanted. And some of that was hit and miss. That's okay. Really, for the test, you need to understand here that what's going on with how the for loop works. Basically, you're stepping all the way through the length of the array. How this idea that our 200 by 200 box turns into one 40,000 long pixel, and then how we start manipulating the colors inside as we change them. We can randomize certain colors. We can make certain colors transparent. We can make certain colors respond to the mouse. And then when they're done, we assign each color to a particular pixel, and then when it's done, we write that out. Okay, so let's try another example. I'll finish this one, and then we'll pick up with exercise 3. Okay, so here's exercise 3. Let's have a look at what's in processing. This is Schiffman's example, his 15.6 example, setting pixels according to their 2D location. So this has got two specific loops here, where he goes through and looks at each of these pixels and sets it. So you want, let me just walk you through his, well, first let's look at his example, see what it does. We run it, and it produces this. There's some stripes in here. They're kind of hard to see. In fact, they're hard enough to see that I've got a little zoom of it here. This is what it looks like close up. You can see there are black and white alternating vertical stripes. Okay, so that's what we're after. That's what we're going to try and make. We want to understand it well enough that we can change it. In this case, we want to understand it well enough that we can change it so the stripes, instead of vertical, are horizontal, and instead of black and white, actually change colors as they go. All right? So let's close this and close this and step through exactly what he's doing just to understand. First of all, the obvious one. He's setting the size 200 by 200. That's our friendly size, isn't it? He's going for the load pixels model, right? So both of these are okay. You want to feel comfortable doing them either way. Either creating a P image with a destination or doing the load pixels thing. Both of them work. So what he's going to do here is, instead of immediately stepping through all 40,000 pixels in a row here, he's creating a loop inside a loop. Now, why is he doing this looping bit? He's doing it so that we can think clearly about the X and the Y and which is the X and which is the Y. Before, when we were just randomizing things, it didn't matter which pixel was exactly where. Even when we were looking at the top to bottom thing for that gradient change, even then it only mattered in the really big picture, the between 0 and 40,000 bit. But we weren't paying attention to, well, is that one pixel over? Is that in the left column, this column or this column or this column, right? So here we have to know exact details about the X and Y. So we're setting up a loop here, and this image is 200 by 200, the size of our width and our height. So we're going from 0 to less than 200, and then Y is doing the same thing except with the height. So we are essentially going to be looking through every pixel. And then there's this formula here. This formula for working out where in that long 40,000 pixel array this is. Now, that 40,000 pixel array is always there. That's how processing and Java are always thinking about it, you know, underneath the hood. When you're not looking, it's still there. So here's the formula. We're coming up with a variable called lock, and for location, and we calculate it by saying it's the value of X plus Y times the value of width. And if you think about that, it makes sense. This is the width. The width is from one side to the other. Say on our picture here, that's our width. So we want to go through this. If we go down, if our Y is, say, 100, which takes us to the middle, then it'll be 100 times this many across, right? Because every time we do a Y, we are going across by 200. So it'll be 100 times 200 is 20,000, right? So that adds up, and then you fine-tune it with the exact location with the X. Now, here's the secret. It's always the same formula. You're always going to do this pattern here that I've got highlighted. A loop for the X on the outside, inside that a loop for the Y, and then this formula here where whatever we're calling it, location or my pixel or I or now or whatever, and it's always going to be X plus Y times width. So you can memorize this in the same way that you think about any kind of design pattern, either a graphic design pattern, software design pattern, or anything else. It's the way to do it. It always works. Now, to the specifics of what Schiffman's doing here, he has a little bit of modular arithmetic. Now, we met modular arithmetic many times over. The percentage sign means we're going to take X, we're going to divide it by 2, and then we're going to pay attention to the remainder. Yeah? So not what do you get when you divide X by 2, but what's left over after you divide X by 2. So in this case, if X divided by 2, or mod 2 is equal to 0, that means there's nothing left over when you divide it by 2, which means that it's an even column. That's a way to calculate an even number, right? You divide a number by 2, and if the remainder is 0, that means it was perfectly dividable by 2. There's no fractions. So if that's the case, then we're saying that this particular location, remember we calculated location up here, in the pixel array was summoned up here, is going to be 255, which is white. Otherwise, that's the else, we're in an odd column. So then we're going to make it black. So essentially it's just saying, is the X location odd or even? And if the X location is even, it's white, and if the X location is odd, it's black. And you'll go through all 40,000 pixels that way, mark them up, and come up and update it. And that's what gives us those stripes. So if we want to change this to our model example, okay, so here's our example. We're trying to go at this. It's a little hard to see, so maybe we should zoom in on it. If we look really close, that's what you're actually seeing. Red, green, blue, red, green, blue. See? Really close. Red, green, blue as stripes. It's interesting that as you shrink it down, it becomes more and more blurs and looks almost white to us, right? The more you shrink it down, the more it becomes a white or maybe a gray color. That says a lot about the optics of red, green, blue combining to be white or gray. Okay, so let's hide that one away and try and work out how we're going to get there. So, two problems. One is vertical to horizontal. Second problem, black and white to color. Third problem, three problems. And third problem is two options, black or white, to three options, which is going to be red, green, blue. So let's do the easy one first, which is horizontal to vertical. Well, try vertical to horizontal. It's here we went through and we checked x, right? Is x divisible by 2? If it is, da-da-da. If it's not, da-da-da. X changes as we go across. So as we go over a little bit, it's one, over a little bit, it's another. Those end up being columns. If we change this one to y and we do it, there you go. The stripes are going this way. No, it's a little hard to see, but they are for sure going horizontally. So in one character, we solved the first problem. Woohoo! Next thing we need to do is to deal with three possible possibilities rather than two. So in this case, instead of having an if-else, remember that we could say this with two if statements. It's technically less efficient if we change this to just say if y mod 2 equals 1. But this works exactly the same way. If I run this, ta-da, it's the same thing. So the reason I don't normally do this, and I normally use the else statement instead, is that it's technically faster in terms of processing load. But what we're doing here is still insignificant in the terms of what a modern computer can deal with. So we don't need to sweat about that too much. So in here, this is a 0 and this is a 1, because when you divide something by 2, those are the two possibilities, right? You either get a remainder or you don't get a remainder. So we want three possibilities. So we really want to be dividing by 3. Yes, you guessed it. And if we divide by 3, there are, in fact, 3 options. Yes, there's a remainder of 0, a remainder of 1, and a remainder of 2. So we can make this one a remainder of 2. And now we just need to have the right kind of outcome here. Color 0, color 0. And here we'll have one stripe and then of white and then 2 stripes of black. Let's just see what that looks like. Oh yeah, there, you notice it looks darker? We can actually see it getting darker now. But why not just change the color here? We can just say, here's 1, and we're going to say comma 0, comma 0. And then here we'll say 255, comma 0, comma 255. And then here we can say 0, comma 255, comma 255. And that should do it. Oh, except the colors aren't right. What's going on there? Oh, look at here. We've got 2 zeros, and then here they aren't 2 zeros anymore, right? So we want 255, 0, 0. Then what we want, I got it backwards. Then we want 255 in the middle and 0 on the sides. So we get pure color in the middle. And then we want pure color at the end. That looks like it's going to give us what we want. Yes, there we are. And I can tell you now, getting close to the screen, squinting a little bit, it is in fact going red, green, blue, red, green, blue, red, green, blue. So we've achieved our goal. Okay, so that's it for Processing and Media Part 1. You can join us soon for Processing and Media Part 2.